What do you have to do if the problem doesn't give you time? If you know where you started, where you ended, but you just don't know when. That's easy. We've been doing that for weeks. Where you started, up high, where you'll end up, down low, how you picked up speed, well, you lost gravitational potential energy and you gained kinetic energy. This isn't 1D kinematics. This is before and after. This is very straightforward. We can find out how fast something is moving when it gets down here. No trouble at all. At the start of the problem, you start at a certain height. You have kinetic energy. How much? 1/2 mv squared. Which v? It's got to be the initial this time. No more v. You got to label it. We got 2 now. We got a grand total with potential and kinetic energy ready to spend. Carry it over. You'll still have the same total as before, only you'll have spent some of it, not all of it, on your new final kinetic energy. You're at a new place. You're over here. You are not at 0. You are at a new height of smaller h. You're trying to find out your final speed, for which the kinetic energy will be very helpful, because you know that all of your total is still in potential and kinetic with no work done by any other force. Therefore, we have your old total equals your new. Press pause on the recording and solve as far as VF squared. When you have VF squared equals, press play to check your work. First thing we have to do, divide everything by m. As we said last chapter, mass doesn't matter. Next stop, we got to get that 1/2 out of there. Multiply everything by 2. After that, we need to get the VF squared by itself. Resist the urge to move the VF squared. Move 2gh to the other side. You'll have, when the dust settles, 2gh minus 2gh plus vi squared equals vf squared. Well, we could simplify that. 2gh minus h. Wait a minute, minus. Minus. We've seen minus before. Minus means delta. It means some sort of interval, like a time interval, or a change in velocity, or a change in displacement. Hey, hey, hey. Change in displacement. This is the change in displacement. Over here. You started at a displacement of h, and you ended at a displacement of little h. Little h minus big H is your change in displacement. I see something else I recognize too. G. G stands for the strength of the gravitational field, aka the acceleration provided by gravity. Gravity is what's accelerating us. Only it's accelerating us in the downward direction. Now substitute these two into our work here. Check your work. And when you are all done, you should find that Vf squared equals Vi squared plus 2 times acceleration times your change in displacement. Fifth equation of motion, 1D kinematics, what to do when you don't have time. Don't worry about it. You didn't have time for before and after either. Now, wouldn't it be nice to take the square root of both sides and get Vf by itself and solve for final speed? A, no, this plus sign isn't going anywhere. Take a square root, you'll only make the problem more ugly. B, Vf can be negative. Specifically in this case, our final velocity is going to be going down. Take the square root, you're going to risk losing that negative. Keep it as Vf squared and check the problem. If you can clearly see it's going down, stick a negative in front of it yourself. It's not going to get any prettier than this, but this is a shortcut we can use. Let's by all means use it.